This video is on exponential functions. An exponential function is a function that has a constant base, that is, the base is a number, and it's raised to a variable power. It's raised to a power of x. The basic equation is y equals b to the x, where b is not equal to 1. Notice why b can't be equal to 1. If b were equal to 1, you would have y equals 1 to the x, and 1 to any power is always 1. So b can be greater than 1 and b can be less than 1. If b is greater than 1, then the graph represents exponential growth. Here's an example. Here's a table and a graph for the function y equals 3 to the x. So notice that your variable is in your exponent, and it's going to give you some of these values here. Let's try it like 3 to the 1. So when x is 1, y is 3. When x is 2, y is 9. You'll notice that the graph grows very fast, okay, and also gets going the opposite direction, gets very close to the x-axis. That's exponential growth. This is actually a tripling function. Every time you put in a number, you're tripling that number. So the next value would be if x were 3, 3 to the third power is 27. If b is less than 1, then the graph represents exponential decay. So an example of this is y equals 1/3 raised to the power of x. So just a couple points on this graph. When x is -2, 1/3 to the -2 is 9. And that would be this value here. When x is 0, anything to the 0 is the 1 power. When x is 2, y is 1/9. So you can see that this graph is going down very close, getting close to the x-axis and decreasing very rapidly. Notice that these graphs are not linear. They are not a straight line. Therefore, they do not have a constant rate of change or a constant slope. For exponential growth, as x increases at a constant rate, y increases very rapidly. For exponential decay, as x increases at a constant rate, y decreases very rapidly. A good example of exponential growth is compound interest. Now, just a word about interest and money. Interest is the amount of money that you can earn on an investment. There are two types of interest. One is simple interest and one is compound interest. Simple interest is a percentage based on the amount of money you deposit. So for example, if you deposit $100 at 2% interest, you receive $2 in interest every year. 2% of 100 is $2. Compound interest is a little more interesting. Sorry, no pun intended. The bank starts out by paying you the $2 based on the $100 you deposited. However, your next payout is based on the total amount you have accumulated, that is $102. So instead of calculating 2% of $100 every time, they calculate 2% of $102. And then after they add that 2% to 102, then they calculate 2% of that number. So it continues to build and grow on itself. Simple interest is calculated with the formula I equals PRT, where I is the amount of interest you earn, P is the principal, that is the amount of money you invested, R is the interest rate, written as a decimal, and T is the time that you invest the principal, the amount of money, in years. Since the interest rate is always calculated on the principal, simple interest is linear. Compound interest is calculated with this formula. A equals P times the quantity 1 plus R over N raised to the power of N times T, where A is the total amount, that is the principal and the interest that you've earned, P is the principal, the amount invested, R is the interest rate, written as a decimal, N is the number of times a year the interest is compounded, and T is the time that the principal is invested in years. Since the interest is added to the principal, the investment grows much more rapidly. Compound interest is exponential. Here's a nice graph that shows how much more rapidly compound interest, that is exponential, grows to simple interest, which is linear. So if your initial investment is this amount here, simple interest just grows as a line. However, compound interest, because it compounds on itself and continues to, the interest is calculated on whatever previous interest you earned, grows much more rapidly. So here's a couple problems I'd like you to try. The first one using simple interest and the second one using compound interest. And if you would stop the video, copy these into your math journal and give them a try yourself. Okay, let's take a look at this example. So you invest $1,250 at 3.5% simple interest for 5 years. What is your ending balance? So interest, oops, hold on. Okay, sorry about that. So your interest, so you're going to use the formula I equals PRT, where your principal is $1,250. Your interest rate is 3.5%, which written as a decimal is 0.035, and your time in years is 5 years. So your interest is $1,250 times 0.035 times 5, and plugging that into your calculator, you get that that's $218.75. Now that's just the amount of interest. To find your ending balance, you need to add that to $1,250. And after 5 years, my ending balance is $1,468.75. Second example here uses compound interest, and it says you invest $750 at 2.5% compounded quarterly for 3 years. I don't know why there's a question mark there. What is your ending balance? So let's identify our pieces here. So my principal is $750. My interest rate is 2.5%, which is 0.025. My n, the number of times per year that it's compounded quarterly. There are 4 quarters in the year, so my n is 4, and my time is 3 years. And I'm going to use the formula A equals P times the quantity 1 plus R over n raised to the power of n times t, or 750 times 1 plus 0.025 over 4 raised to the power of 4 times 3. And plugging that into my calculator, I like to do it in multiple steps. I kind of start on the inside and work my way out. So I would do 0.025 divided by 4, enter, plus 1, enter, raised to the power of 12, enter, times 750, and I get $808.22. Remember, you always want to round money to 2 decimal places. So in this video, we took a look at exponential functions, exponential growth, exponential decay, and in particular, an example of exponential growth being compound interest.